Okay, good evening, everyone. Okay, let's start with the today's session. I think there is yes. Okay, yeah. So last class we are discussing about that is probability distributions. Okay, and today we'll cover about normal distribution, and also we'll discuss about the net-based classifier. Okay. So before coming to this net-based classifier, this is a part of one of the statistical technique, okay, for classification purpose. So before starting this, you should know what is a machine learning algorithm is. Then we'll come to this classifier, okay. So point is that when you are means machine learning algorithms, maybe it is a classifier or a clustering algorithm. Okay, so classifier means it is a means when you are training means when you are training the means the machine, then after the training process, it is able to predict whether it is belonging to class 1 or class 2 or class 3, whatever. Okay, so classification is one of the technique by which the algorithm is goes through a number of training process. After the algorithm is being trained, then it is going through a testing process. Okay, so prior to this, means for classification purpose, uh, the algorithm is we know prior to the algorithm is being tested, we know what is the class levels of each data points are. Okay, if there are n number of data points, for each data points we know what the class level of each data points. Based upon that, we are able to train the model. Okay, so there is for machine learning purpose. So machine learning is one of the technique by which we are training the machines in terms of it is a algorithm. Okay, so I mean, so what type of decision it will take. So all these things can be possible when we are training the machine. So that is one type of machine learning algorithm. So machine, it is of two types. One is classification, another is clustering. So in classification, the class level of each data points are known, and the unknown data point class level will be predicted. So point is that suppose there are n number of data points available, okay, and that will be fed to the machine. The based upon the its feature, the machine will learn that suppose for a particular example, there are suppose 10 number of data points are there, and each data points are having some values. Suppose one is weather condition, whether it is raining, whether it is sunny, whether it is some other attributes are there. Okay, so based upon that, we are having some class level, that is whether we can play the game or not. Okay, so the class level is either yes or no. If it is a binary classification problem, so the class level will be either 1 or 0, whether it is we can play or we cannot play. Okay, so here the machine can learn this means based upon the historical data, that the historical data will be called as training data. Okay, so the like you are able to understand when you are driving a car, you are able to judge that whether you should take left or right based upon the RMR given in the road. Okay, so because all these things you have come across earlier, you may have gone through a number of training, or you have seen this type of problem earlier. So that's why you are able to take decision whether you want to take left or you should take right at a particular point in a road. Okay, so that is one of the thing that similar way the machines can also learn from its historical data. So that historical data we can say we can give that machine that historical data in terms of training data. Okay, so in classification problem, each data points will have its own class label. If if there are n number of data means attributes are there in a data point. So suppose one example is whether we want to detect whether the patient will means if he is serious or he is a minor having minor problem we want to detect. So he is having suppose blood sugar level some value. Suppose what is its what is his means blood temperature means body temperature. All these things are some means criteria by which we are all these are the symptoms of a particular patient. Based upon that we are means judging whether he is a critical patient or he is a normal patient. Okay, we can he is a patient obviously, but whether he is in normal condition or he is in serious condition, that we can judge. So point is that when an unknown person will come, the machine can detect based upon the particular criteria by which we have trained the machine earlier. Okay, so point is that that is one type of problem called as classification problem. The we will give some data means historical data to the machine. The machine will learn based upon this historical data and just okay, historical data. The machine will be trained, and after it will go through number of stages of training, then it will be tested. And when the testing, the machine will go means certify some number of the accuracy level is high. Then we can say the machine is well tested, and it will be given to the market for real life means problem solving. Like when unknown patient will come, the machine can judge his body temperature, his blood sugar level, or his any other problems, symptoms he will detect, and these input will be again given to the machine, and the machine will able to detect whether he is a critical patient or he is a normal patient. Okay, so that is one type of task is called classification. Another task is called clustering. So clustering is what we will given a number of data points. Okay, and the class label is not known to us, so we have to find out number of clusters out of these data points. Okay, so these are the two different techniques in machine learning. Okay, already we have come across regression. Okay, so these three types of things we can be possible we can apply in machines in for prediction for means regression analysis. Okay, so now we will see one of the classification technique is called Bayes theorem. Okay, net Bayes classifier, and that classifier is being designed by this statistical technique is called Bayes theorem. Okay, so the Bayes theorem itself will derive the Bayes theorem. Just see, already I have one note for you. Then we'll come to this slide presentation. I have this 10 number of slides for you. So now let me see whether I have recorded the session. Okay. So suppose this is the okay. We'll derive this Bayes the Bayes theorem. So Bayes theorem is exactly this one. Okay. Probability of A given B equal to probability of B given A into probability of A by probability of B. So here the left side is called posterior probability, and this one will be called as likelihood, and the next one, the probability of A, is the prior probability. Okay, and the denominator is called marginal probability. Okay, okay, just hold. So the denominator is called marginal probability. So we'll derive this equation. Just see how Bayes theorem is being derived. Suppose we will first go through this conditional probability which you have learned earlier. Suppose there is a for example there are five marbles available in a basket, and there are the types of marbles are red marble and black marble. So the probability of getting a black marble will be there are two outcomes. So 2 by 5. Okay. So after this event will occur, the next event is suppose again you want to take another black marble. So it will be 1 upon 4. Okay. So this is when simultaneously you are taking two marbles one after other. Okay, so this is called conditional probability because the second event depends upon the first event to occur. So suppose this is probability of event A and this is event B. Okay, this is a event B and this is event A. So the event B depends upon event A. Okay, so now just see. Uh, Okay, to find this, okay, over here, probability of B given A equal to 1 by 4. Okay, B given A means, so this is condition. Okay, probability of B given A is, means probability of B given the A event has already happened. Okay, so that we can write in this way. So probability of B given A equal to 1 by 4. Again, probability of A intersection B, that is this one, equal to probability of A event into probability of B event. So this is 2 by 5 into 1 by 4 equal to 1 by 10. So now probability of B given A equal to probability of, this is conditional probability as I already discussed earlier. Probability of B given A equal to probability of A intersection B by probability of A. So that's why we calculated these two terms, values. Okay. So probability of A given B equal to A intersection B equal to 1 by 10 by 2 by 5. This is probability of A is 2 by 5. The A event is this one, is this event. B is the next event. So now this is a dependent event. Okay, this one is a dependent event. Now, base theorems, how we can derive the, just see, this is the thing we have come across. Probability of A given B equal to probability of A intersection B by probability of B. Okay, and probability of B given A equal to, that means probability of A given B means already B event has occurred. We want to calculate the probability of A when B has already happened. So this type of probability we can calculate with this formula. Okay, so here probability of B given A equal to this one. Okay, same A intersection B and this is B intersection A. So as you know, probability of A intersection B equal to probability of B intersection A. So that's why we can calculate. Okay, now we can equate these two terms, probability of A intersection B and probability of B intersection A. Then if these two are same, then we can write that probability of A given B into probability of B. This one just to be multiplied. Okay, and we got probability of A intersection B equal to probability of A given B into probability of B. Similarly, probability of B intersection A equal to probability of B given A into probability of A. So now you can equate this right side. Okay, so probability of A, probability of A intersection B and probability of B intersection A. So you can equate this probability of A intersection B equal to probability of B intersection A. So now probability of A intersection A given B equal to probability of B given A. From this equation you can get probability of B given A event has already occurred into probability of A by probability of B. That you have to remember this equation. Just see if whatever the event is given already, so that thing probability you can calculate. Okay, but now you are interested to find the probability of A. So this one is you have to put in the denominator. Okay, and if you want to find probability of A given B, obviously you should have this probability of B given A. You should not have probability of A given B to calculate this A given B again. So now you have to write probability of B given A. So that is the called likelihood. Of the term is called likelihood. Okay. So now this probability of A you can calculate, which is not dependent on this the other one, the B event. So this one is a prior probability you should calculate. Okay. So these things will be given and you have to calculate the posterior probability, that is probability of A given B. So this one is called posterior probability and this one is called marginal probability, probability of B. Okay. Now this one will not discuss now. We'll come to this example. Okay. So this Bayes theorem is the one which I discussed just some time before. It is named after Thomas Bayes. Actually, he was a scientist. He was in search of proving whether God exists or not. That's why towards the end he just concluded with this theorem. In 18th century, he has invented this formula. Okay, how effective is Bayesian classifier? So we'll apply this Bayes theorem in classification purpose. So this type of classifier is giving minimum error rate comparison to other classifiers. We'll come to know later. Okay. So posterior probability is the probability. Posterior probability, we can also say posterior. Okay. Okay. The example is I have missed. Okay. So net Bayesian classification. So statistical. It's a statistical classifier performs probabilistic prediction, that is predict class membership probabilities such as probability that a given tuple belongs to a particular class. Okay, so this one is a net Bayesian classification is a statistical technique for classification purpose. Okay, it is based on Bayes theorem, and a simple Bayesian classifier, net Bayesian classifier, has comparable performance with decision tree and selected neural network classifier. So these are some machine learning algorithms. If you have already completed data mining course, then you have come across. Otherwise, not an issue. We'll discuss it after some lectures. Okay, in the upcoming module. But thing is that this net-based classifier has comparable performance. That means it is performing better then this decision tree and selected neural networks. Why it is written selected neural network? Because nowadays means convolutional neural network has come. So now the convolutional neural network giving better performance than any other means classifiers. So now that's why we can say for selected neural network classifiers, this one is performing better. The net-based Bayesian classification classifier is performing better. Okay, so Bayes theorem itself, just I told you that it is probability of h given x. H is a expectation we want to find for what is the probability of h, and given the event x has already happened. So that is probability of x given h, and probability of h. This is prior, this is likelihood, this is marginal, and this is posterior probability. Okay, so this one is equated to probability of x given h into probability of okay, the same thing. So let x be a sample or evidence. Okay, that x event has occurred. Okay, so the class level is unknown. Let H be hypothesis that X belongs to class C. So we want to calculate the probability of H. So that is a hypothesis. So classification is to determine probability of H given X, that is called posterior probability. Okay, and the probability that the hypothesis holds given the object data sample X. So probability of H, which is unknown right now, we want to calculate with the condition that X has happened. Okay, so it will be given that something is there with you, some data means knowledge is given over here. Now based upon that, you have to, on that condition, you have to calculate what will happen on this class level. Okay, so that's why on the overall condition, you can have this probability of H. Okay, so probability of H is equal to prior probability, the initial probability. So we'll discuss this with a simple example just sometime after. Just see, X will buy a computer or not, that we can predict. This is one example we are going to discuss, regardless of age or income. Probability of X, probability that sample data is observed. Okay, probability of X given H is the likelihood, the probability of observing the sample X given the hypothesis hold, given that X will buy computer probability. Okay, next come to, so given training data set X, posterior probability of hypothesis H, this posterior probability we have to calculate. This theorem is the terms already I discussed. Okay, so predict X belongs to Ci is the class level if the probability of Ci given X is the highest among all the. So this one we can see with the example. Okay, suppose we will be given some data points having some number of attributes. Okay, so the data points will be called as training data set for training the classifier, and suppose there are m number of classes. Okay, there are m classes, that is C1, C2, Cm. Classification is to derive the maximum posteriority, that is maximal probability of Ci given x, for which this probability is maximum, that will be the result. This can be derived from Bayes theorem. Okay, since probability of x is a constant for all classes, only needs to be maximized. So probability of x is the denominator part, so that we need to truncate it. Okay, so just see, instead of writing probability of the likelihood into prior by means extreme probability, that is we have to then we can, because we have to compare all these probability uh, based upon whether it is no or yes. Suppose it is the task to find whether the person will buy a computer or not. If it is the class level is only binary class, so it is yes or no. So you have to calculate probability of x given it is yes, probability of x given it is no. So whichever will come to the right, that will be come in the denominator. So that's why we'll not consider the denominator part. So here is an example. Just see here, 14 data points are there and number of class levels are there. So the class levels are no and yes. So we have to predict whether on this particular condition, the condition is if the person is these are the data points already available, means already collected from historical data. If the person who has brought a computer from the market, he has some information given to the store, that is he is youth and his income is high and he is a student. It's not he is not a student and having fair credit rating. Credit rating is you may be able to understand, that is under a particular purchase you are getting given a rating. So whether he is fair or excellent, that is given over here, and whether he can buy or not, that he has brought it earlier or not, all these things are some historical data. So but this is person 1, person 2 up to person 14 data are available with us. Okay, so this data is from all electronics customer database available in the internet. Okay, so now just see. Okay, the two classes are there. One is person can buy computer or person cannot buy computer. Okay, so yes or no. Data to be classified. This is the data. If the person data is given age equal to youth, income equal to medium. Okay, if a person will come and he is having these informations, that is he is a youth and he is having income source type is medium, he is student and having credit rating fair. So we have to calculate what is the class level for this types of information available for a particular person. Okay, so for that we have to apply the Bayes theorem. So Bayes theorem says probability of buying computer equal to yes, that is equal to how many number of, so just you have to follow this means training data. So this training data says that over here this these are number of yes and no are there. So how many yes and how many no are there? So buying computer, that is we want to calculate the prior probability, which is part of the Bayes theorem. Okay, so prior probability we have to multiply with likelihood, then we can calculate the probability of a event subject to the condition he is having this type of informations. Okay, so probability of yes we have to calculate, and probability of no we have to calculate subject to the condition. These are the informations. Okay, so probability of yes, to calculate it we need to find probability of means prior probability without any condition. Okay, here the formula says that we have to calculate the prior probability without any condition, that is p of h. Okay, whichever is being asked, that you need to calculate. So that is probability of yes, buying computer equal to yes equal to 9 by 14. Just come to here, 9 number of yes are there out of 14. 1 2 3 4 5 6 7 8 9 number of yes are there. So 9 out of 14, so 9 by 14 is the probability of prior probability, that is 9 by 14. Similarly no is how many? 1 2 3 4 5. So 5 out of 14 is the prior probability of no. So that much is 0.357. So for computing probability of x given ci for each class, so that means this is called likelihood. Okay, this terms we have to calculate. So probability of age given youth means age is youth, given he has brought a computer equal to yes. Okay, so probability of youth given he yes, okay, that is 2 upon 9, that you can see over here. Probability of how many youths are there, and the class level is yes. So this is not calculated one, this is also not one. Youth again over here, it is also no. So this one is calculated as 1. Okay, outcome is 1 now. So another one is here. So 2 upon total number of years is how many? So youth is once. Just see, this one is a, okay, youth. This one is youth, and this two. Any other I'm missing? One, two, and this one is also youth. Okay, total number of 6 number of data points are there, where it is have available that youth equal to no youth. The total number of attributes having youth age as youth is 5 number of times. Out of them, these are yes, so these two are yes, the other are no. Okay, so that is 2 upon how many? 1 2 3 4 5. Out of 5, okay, out of 9 records, 2 upon 9. So how many are having yes? Just calculate how many are yes. Given it is yes, this is the conditional probability. Probability of youth given yes. So you have to calculate how many are yes there, and among yes, how many are youth. Okay. So just calculate yes. How many number of data points are having class level as yes. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9. So out of this 9 years, this is the means condition. So youth given yes. So that is these two are having which one? This youth one and this one. So 2 upon 3 plus 3 plus 3 9. So 2 upon 9 is the probability that probability of youth given buying computer equal to yes. Okay, so that is 2 upon 9. So 2 upon 9 is the probability of calculating probability of youth given buying computer equal to yes. Similarly, probability of youth given buying computer equal to no is how many? So out of means 14 number of data points, 9 we got yes, then remaining 5 are no. So among the no, just calculate the probability, how many probability are there, means how many data points are there where it is a youth. So 1 2, okay, and this one 3, the previous one, okay, 3. So 3 upon 5. So 3 upon 5 is the answer. So 3 upon 5 is the answer. Probability of youth given no. So why I am calculating all this? You just have to know that after calculating all this, you have to apply over here. Okay, you have to this one is as this one is youth. Similarly, okay, you see, age equal to youth, income equal to medium. This one, this is the given information. Student equal to yes, credit rating equal to fair. So you have to calculate probability of according to best theorem. Probability of means yes given this x value. Okay, so that is probability of the right side of the best theorem is likelihood we have to calculate and multiply with the prior probability. So the likelihood will be calculated like probability of x. X means it's not a single term. It is dependent on number of means attributes. Okay. So these attributes are in the base theorem. It is assumed that all are independent among each other. Okay. Class conditional independence, that is called. That's why it is called naive Bayes classifier. So these among these attributes they are not dependent. So we can calculate the probability of x given the person can buy computer equal to, we can multiply each individual probability among each other, then you will get this one. If there is some means conditional means there is a condition between the two, then the probability will be value will be changed, because we are assuming that between these events means age, income, students, all these are at the beginning it is assumed that all are independent. Okay. So all these are considered as independent events. So that's why we are multiplying the probability of each individual event. That is, youth given it's a yes, medium given it's a yes, student equal to yes, given by computer equal to yes, fair given it's a yes. So that all these things we are multiplying over here. So probability of credit rating fair given he can buy computer, he has brought computer, that is 6 by 9. So this one is the last term I multiplied. Now the first term is probability of youth given by computer equal to yes. So probability of youth given by computer equal to yes, so 0.22 triple two, and all these terms I am multiplying. Only I am multiplying at the beginning with the terms which are for which the means condition is by computer equal to yes. Okay. We are calculating youth given by computer yes, we are calculating income medium given by computer yes, student given by computer yes, fair rating fair given by computer yes. All these probability will be multiplied together to find probability of yes given x. Okay. So that is Bayes theorem itself. So that's why we are calculating this likelihood, the probability of x given C1. So there are two classes in this data set. Okay, in this data set there are two classes. So we are only calculating probability of x given C1. Similarly, probability of x given C2. Okay, and here instead of yes and no, we can calculate some other values. If it is high, medium and low, if there are three classes inside the data sets, then we can calculate the probability of each means class level with respect to these conditions. Okay, and multiply at the end, we have to multiply all these terms to get some likelihood value. So after getting the likelihood value, we have to multiply with the prior probability. We have to multiply with the prior probability, that is probability of by computer equal to yes. So that one we have already calculated at the beginning. So that is 0.064064 into probability of x given it is a yes. So these two terms after multiplying we got 0.028. Similarly, probability of by computer equal to no into probability of this one. Why I have omitted the marginal probability, because in the other term we have to divide this common term, so I have not calculated that one. So that one that difficulty is being means that is not required to calculate. Okay. So x belongs to, so now we got that out of these two events we got that 0.02 is maximum out of the probability of yes given probability of uh, this is probability of yes given this x term is 0.028. Probability of no given these x terms is equal to 0.0007. Among these two, this one is having more value, more probability. So the result is the, therefore x belongs to class by computer equal to yes. Are you able to get my means points? Yes or no, everyone? I think this is a simple example. It is also available in data mining book. if you will go through, you will get this example. This data set is not available directly. You can search it in Google, you will get this image. Okay, and now in this image you just refer this image to understand this concept. Okay, how Bayes theorem is derived, all these things I discussed sometime before, and you apply that one over here. This is called means prior probability. You have to calculate prior probability of yes, prior probability of no, and multiply with the likelihood of yes, likelihood of no. Okay, then multiply these two terms and you will get some values. So that will be among these two value you have to find whichever is larger, so higher probability, that will be considered as the class level of this unknown data points. So this unknown data point is having, suppose a person came and he is a youth, and he is having income source medium, and he is a student, and at the end he is also having credit rating fair. So we can say we can predict that that person, when he enters to the shop, he will predict that the person will buy the computer. Okay, so we have to advertise, we have to means pass some information to the agent or whoever is in the shop, that you should convince this person because he is a customer. According to our means software or this program, it says that the person will buy the computer. You have to convince, or you have to talk in such a way that he will he is in a mood to buy. But if you will not talk in the right way, then maybe he will be, will lose one of our customer. Okay, so my point is that similar way we can also this type of algorithm, we can also apply in banking process, where the bank manager will predict whether the person can return the loan or not. If he is a youth and having job, having also he is driving a Mercedes car, then we can means, approve his loan with 10 crores. So that can be possible. Okay, so we have to calculate whether the probability that the person will able to return the loan after it is being sanctioned. Okay, means after some year. Okay, so the point is that this way we can predict. So you can go through the example, also go through the theory to understand the concept, and you apply in means in your real life example, real life problems. Okay, so now, one problem with this algorithm, this statistical technique is that if somewhere you will get that the person doesn't have this, suppose we want to calculate the person age is youth, and nowhere we got in the data set, nowhere, suppose there is a condition that nowhere we are getting a yes. Okay, so by chance there is a yes for places where we got yes. Okay, if that is the means, situation, then what will happen to the probability of likelihood of probability of this youth given yes? So it will be 0 by 9. Okay, so 0 by 9 is equal to 0. So if you multiply that 0 over here, then you will get a round figure 0 over here. So due to that problem, means you will not able to calculate it properly, which one is more chance to happen in the future. So for that you can introduce a because the data set which is given for to you to predict the future, that that is not a small amount of data. For example, we have taken a small for understanding the concept easily, we have taken a small amount of data where it is only 14 number of data points, but in the real life it is given like 1400 number of data points, or 5000 number of data points will be given for to you for prediction purpose. Okay, so now also you can consider the data set which is a weather data set available in internet. You can search in Google image search, and you will get a image like this. Somewhere it is whether you can play cricket or golf or something like that. Some data sets are available. Okay, based upon some weather, and whether it is sunny or cloudy, all these things are there. Okay, so based upon that, the net based classifier you can means model using this statistical technique. Okay, so my point is that I was discussing that somewhere you will get this problem that number of youth is suppose nowhere it is found that the class level is yes. So that is the problem. So if the data size is small, then it's a problem. But if the data size is very large, if you are using a dummy data point over there where it is intentionally you are making this not null, not zero. So our main intention is to make this probability multiplied properly so that we will not get anywhere zero value. So for that we have to introduce intentionally some dummy data points inside the available original data points. Okay, so intentionally just put a youth and class level is equal to yes, because no here there is a yes. So this way you can solve the problem. Okay, so here it is written that net Bayesian plus prediction requires each conditional probability be non-zero, otherwise the prediction probability will be zero. Okay, suppose a data set with 1000 tuples, income equal to low, income medium equal to this much, income equal to high. So use Laplacian correction. So anywhere you are getting a zero, just put one. Okay, if it is okay, it is a zero income level. So instead of that, you have to write 1 by 1003. So you just increment the number of data points by 3. Okay, maybe more than the original data points. Okay, so this way you can solve the problem. So this is all about this net-based classifier and the Bayes theorem, part of statistics. Okay, it is a statistical classifier. You have to understand that one. Okay, so after this we have to discuss this one. Already I have solved it, but you have to understand with the data set. I have not downloaded it. I will maybe later point of time I will discuss. Here actually there is some data similar to the tabular format data I just shown you for whether the person can buy computer or not. Similarly, there is a data set having some temperature, weather, all this. So we have to calculate probability of yes, given it is today's weather. So today's weather is it is sunny, hot, and these are the two conditions. Suppose so we have to calculate whether we can play game or not. Okay, so based upon the probability, we have to compare this one. Yes, probability is 0.031 and no probability is 0.08571. So among these two, this one is more. So it is obvious that we have to conclude that we should not play the game. Okay, because of the temperature which is available, historical data is available with us, and that data based upon that we concluded. Okay, so you just go through and I will solve this problem. Okay, now come to the other statistical technique, that is I have already told you last class. Just a minute. So it was about random variables already discussed and continuous distribution is already discussed, and now the remaining part is the normal distribution. Okay, so normal distribution is okay, just see. So it reflects the features of distribution or observation around the mean. Okay, in okay, we'll have one more session, uh, then we'll start. Okay, so before starting our normal distribution topic, last class I have told you, I have shown you one curve. Okay, so that curve was looking like, let me off over here. So this is a plot. Okay, and the distribution will look like this type of curve. Okay, okay, this is a normal distribution. Roughly, I am not able to correct it, so I will show you in the paper itself. Okay, so the point is that maybe somewhere it is yes. So this is exactly a normal distribution where the mean, if you calculate the mean of the distribution, it will be in the middle of the distribution. So it is if the curve is look like this. Okay, so the mean may arise over here because more data points are over here, the more values are over here, that's why the mean is going away from the middle of the the plot. Okay, so it is going towards left. Okay, if it is uh, okay, if the plot is like this, if the plot is like this, so mean will come here, not here, because there are small data points are available over here. If these are all data heights of, or suppose income of a particular of number of persons. Okay, if we will find the mean average income of persons in India, then we have to the mean you will get towards the here. Even if a person is not able to get its basic need, still we are getting the mean over here, not here. That means the mean value will say that the Indian average income is this one. Suppose 5,000 is the per day income, means 5,000 amount of money a person is, person's income, regular income. Okay, but actually the person's income is 50 rupees per day. Okay, maybe average, if you calculate actually, if you ask a person somewhere in India, you will get that the total the per day income is 50 rupees per day. Okay, but actually when you calculate this mean, you will get 500, because some other persons are there. Those are industry, means entrepreneurs. They are having more money with them. That's why the mean is going towards top. Okay, but here this is a special curve. It is called, also the name is also called Gaussian distribution. Okay, or it has also another name called as bell shape. Or it is look like bell shape. Okay, where the curve is symmetry towards left and right. Okay, and when it is symmetry with the mean value. Okay, wherever the mean will come, if you make a perpendicular in that axis, okay, in that place, then it will divide the whole distribution into two part, and 50% data will come here and 50% data will come here. Okay, so this one is one example of normal distribution. So it means that it, in a set of data, how my observation are distributed around the mean value. Okay, so distribution means it's a set of data, and how these observations are distributed around the mean or central value, so that we can see using this distribution. So this normal distribution is also called as Gaussian distribution or standard normal distribution. These three terms you have to remember: Gaussian distribution, normal distribution, or standard normal distribution. Okay, and why the name standard, that you search in internet. So the characteristics of this distribution is, why it is called normal. For a set of data, most of the value of the observation are clustered around the mean. That's why it is called normal. Okay, so normal distribution means for a set of data, most of the value of the observations are clustered around the mean. That means over here in the distribution, just come to here, the most of that data is available towards the mean. The mean is over here, so in this position most of the data is clustered over here, and very few data are there that are available towards, means right